Somewhere in this universe, there is a place where time nearly stops. Light bends into a glowing ring around absolute nothing, and one invisible line separates everything that exists from everything that will never be seen again. There are objects so dense, they crush a dying star into something smaller than a city. Monsters, so massive they swallow entire solar systems. And there might be ones no bigger than an atom that could erase you before a single nerve fires. Now imagine falling toward one. Your feet accelerate faster than your head. Your body stretches into a thread of atoms. You look back and the entire universe collapses into a shrinking ring of blue light above you. You try to scream, but sound has nowhere to go. Your last image freezes at the edge, because to the outside universe you never actually crossed. You just reddened, slowed, and disappeared. These are black holes. And there isn't just one kind. From collapsed stars barely wider than a city, to ancient engines 6.5 billion times the mass of our sun that anchor entire galaxies, to theoretical ghosts from the first fraction of a second after the Big Bang, every terrifying type is stranger than the last. What you're about to witness is a journey through every kind of black hole that science has confirmed, hunted, or dared to imagine. And it begins with the violent death of a star. A star dies, but not with a whimper. Its core runs out of fuel, and gravity takes over. A force so relentless that nothing can stop the collapse. The atoms themselves are crushed. If the core's mass is above about 3 times that of our sun, not even the pressure from neutrons can resist. The result is a black hole, a city-sized sphere so dense its gravity traps everything, even light. For a black hole 10 times the sun's mass, the event horizon is just 30 kilometers across, smaller than most cities. Yet inside, millions of Earths could disappear forever. These are stellar black holes. They are born from the most massive stars, at least 20 times heavier than the sun. Most are invisible, but when paired with a living star, their presence is revealed. Gas spirals inward, heats up to millions of degrees, and radiates X-rays. In 1971, astronomers found Cygnus X1, a hidden partner tugging on a blue giant, drawing matter into a glowing disk. Decades of measurements pinned its mass at about 21 suns. Its darkness was so convincing that Stephen Hawking once bet Kip Thorne a bottle of scotch that it wasn't a black hole. Hawking lost. Sometimes these monsters come in pairs. When 2 black holes spiral together, they warp space itself. On September 14, 2015, 2 black holes, 36 and 29, times the sun's mass, collided over 1 billion light years away. LIGO's detectors felt the ripple, a rising gravitational chirp as the pair merged into a single, heavier black hole. The energy released in that instant was greater than the light from every star in the observable universe. This was GW 150914, the first direct proof that stellar black holes exist and that space can ring like a bell when they collide. From X-ray flares to gravitational echoes, stellar black holes are no longer just theory. They are real, measured, and terrifyingly common. Yet between these city-sized killers and the giants At galactic centers, a shadowy gap remains. Something is missing in the black hole family tree. At the heart of nearly every galaxy, something vast and invisible holds millions or even billions of stars in its grip. These are supermassive black holes, objects so immense they bend the fate of entire galaxies around them. The Milky Way's own center hides one, Sagittarius, a star, a black hole, weighing in at 4 million times the mass of our Sun. Astronomers tracked a single star, S2, as it raced around this hidden giant, completing a full orbit in just under 16 years. At closest approach, S2 hurtled through space at over 7,000 kilometers per second, tracing an ellipse that could only be carved by an object packed into a space smaller than our solar system. There is no cluster of stars or exotic matter dense enough to explain this gravity. Only a black hole fits. But Sagittarius, a star, is small compared to the monsters lurking in distant galaxies. In the core of M87, a supermassive black hole tips the scales at 6.5 billion solar masses. In 2017, the Event Horizon Telescope, an alliance of radio observatories spanning the globe, linked together to form a planet-sized eye. Their target was the shadow of M87's black hole. After months of sifting through petabytes of data, scientists assembled the image that stunned the world, a glowing orange ring encircling a dark void, the first direct glimpse of an event horizon. The shadow's size matched Einstein's predictions, confirming not just the mass, but the very nature of the beast. Supermassive black holes do more than anchor galaxies. As they feed, they launch jets of energy that can stretch for thousands of light years, blasting gas out of star-forming regions and shaping the growth of galaxies themselves. This feedback sculpts cosmic neighborhoods, turning black holes from silent monsters into cosmic architects. Yet a mystery lingers. How did these giants grow so quickly in the early universe? The seeds of their birth remain hidden, leaving astronomers to wonder what came before the Titans. Somewhere between the city-sized corpses of dead stars and the galaxy-crushing giants lies a gap, a missing rung in the cosmic ladder. Astronomers call them intermediate mass black holes, objects that should weigh in at hundreds to hundreds of thousands of suns. Yet their existence remains a mystery. The problem is not just their darkness, but their subtlety. A black hole with 1,000 solar masses warps the orbits of nearby stars by only a whisper. Its sphere of influence is so small that even the sharpest telescopes struggle to separate its pull from the jostling of ordinary stars. Hints appear in the oddest places. Ultra-luminous X-ray sources sometimes flare with energies too high for stellar black holes, tempting astronomers to suspect a heavier hand at work. But the evidence never lands cleanly. In 2023, the Gaia spacecraft detected a star in the ancient cluster NGC 3201, wobbling with an amplitude of 0.2 milliseconds, barely more than the width of a hair seen from miles away. The initial calculations suggested a hidden black hole of about 2,000 solar masses. Yet fresh spectroscopic data offered another explanation: a pair of smaller black holes, locked in a tight dance, not a single monster. Each new claim meets a counter-argument, leaving the field split between believers and skeptics. For now, the missing link remains just that, a shadow among shadows, its true nature still out of reach. Moments after the Big Bang, the universe churned with energy so dense it could collapse space itself. Some theories propose that these early fluctuations formed primordial black holes, objects born not from dying stars, but from the universe's own violent beginnings. Their masses could range from less than a mountain to hundreds of suns, raising the question, could these relics be the hidden dark matter? For decades, this idea captured physicists' imaginations. If enough primordial black holes survived, they might account for the invisible mass that shapes galaxies. But evidence has been hard to find. Survey teams, including Ogle and Subaru's Hyper Supreme Cam, have searched for primordial black holes by monitoring millions of stars for microlensing, which are brief flashes caused by a compact object passing in front. LIGO's black hole merger data adds another layer, limiting how many primordial black holes can exist in certain mass ranges. In the 10 solar mass range, primordial black holes can make up no more than about 1% of dark matter. Gamma-ray studies squeeze the limits further, leaving the theory on ever shakier ground. At the farthest edge of theory, black holes shrink to scales where the rules of physics themselves dissolve. Imagine a black hole with a mass of just 2 times 10 to the minus 8 kilograms, the Planck mass. Its event horizon would be smaller than a proton, its lifetime a fraction of a second. Here, quantum effects take over. Stephen Hawking predicted that black holes are not perfectly black, but glow faintly. The smaller the black hole, the hotter this glow becomes. For a stellar black hole, the temperature is colder than the cosmic background. For a Planck scale black hole, it blazes with unimaginable heat, evaporating in a burst of radiation almost as soon as it forms. Physicists have wondered if such microscopic holes could be created in high-energy collisions. The Large Hadron Collider, smashing protons together at energies up to 13 trillion electron volts, has searched for the telltale spray of particles that would signal a tiny black hole's birth and instant death. So far, nothing. The absence of evidence pushes the possible energy scale for quantum black holes beyond the reach of the LHC, deeper into the unknown. Some theorists even imagine a cosmic mirror image, the white hole, a time-reversed black hole that explodes outward, never allowing anything in. No one has seen such a thing. In these quantum extremes, black holes become riddles, testing the limits of gravity, space, and time. At this frontier, the universe whispers secrets in a language we are only beginning to decipher. Tonight, supermassive shadows still anchor galaxies, while others lurk unseen between the stars. Each black hole marks the boundary of known physics, a silent riddle in the dark. As we search deeper, the universe reminds us its most terrifying secrets remain hidden, waiting at the edge of what we can comprehend.